Hey, we're going to start demo number 4. You should be on page 4 in your heat transfer packet, and we're going to be talking about convection and radiation, which are also two types of heat transfer. Right behind me you see my house. It's great. It's got 2 floors. It's got the main floor and the basement floor. So I built a model of my house. I know it looks nothing like it. That's fine. And we're going to talk about how heat affects our house. And you'll notice that my house is painted black on the roof, just like my actual house. And I've got 2 thermometers. I've got one in the upper floor and I've got one in the lower floor. And what we're going to do is we're going to take a heat lamp to tell us that that's the sun, just like the beautiful sun out today. And we're going to see how heat gets into our house. So follow me inside and we'll go ahead and do that right now. Okay, as you can see, we have our house set up here under the beautiful sunshine. It's a heat lamp, that's it. And I have 2 thermometers hooked in right here. One's in the attic, we'll call it the attic, and one is on the first floor. And we're going to see how heat transfers over time. So, I'm going to give you some temperature readings as we go, and you don't have to write anything down, just kind of notice some trends as we go. Here we go. 68.9, 67.6, 76.3, 67.7, 80.5, 68.1, 85.1, 68.9. 89.3, 69.4, 93.4, 70.8, 97.9, 71.3, and finally 100.6, 72.5. Here is what our data looks like with a data table and a graph. Why do you think the attic is getting so hot? The black roof is absorbing radiant energy. And what's happening is that's being transferred into heat, and then these molecules start moving faster and then bump into the air molecules that are inside in the attic, and that heats up the attic air. That's called conduction. A lot of people will mistakenly say that heat rises, but it's not really heat that is rising, it's hot air. In this case, our attic got warm not because heat was rising, because hot air was rising. It was because of that radiant energy hitting the top of our house and through conduction then heating the air inside the house. So what we're going to do is we're going to take some data, but this time we're going to flip our house around. And that way now our attic is down below and our first floor is up here at the top. And I'm going to give you some more data and we're going to see what happens. So notice that I drew some blue lines so that you could tell the before we flipped the house and after. And notice what's happening with the data in our first floor and our attic as we watch. It looks like our first floor data is actually going up, so the temperature is going up, and our attic data is going down. And at the very end, in about 10 minutes later, you'll notice that our temperatures reached equilibrium, which means they're equal. When we flipped our house, that means this hot air, because it is less dense, will actually rise and replace the cool air down here, and that cool air will sink back down, which is why our attic started to get cooler when we flipped our house around. We're going to do this test one more time. Same house, black roof, except this time I'm going to use a piece of Mylar space blanket, and we're going to drape it over the top and see how our heat transfer is different this time. One more time, inside. Alright, we're going to do this one more time, except this time I covered the top of my roof with a Mylar space blanket, and we're going to see how heat transfer differs. So here we go. You're going to notice this time that our attic air doesn't get nearly as hot as it did before when we didn't have the space blanket on top. And the first floor actually remains pretty cool. The black roof absorbed the radiation from the light source, but now that we have the space blanket, it actually reflects the radiation and keeps that heat energy out of the house. Not completely, but way better than without the space blanket. We're going to do a quick review. Conduction is heat transfer when molecules of solid materials come into contact with each other and bump into each other. Convection is heat transfer through a liquid or a gas because warmer things are less dense, so they tend to rise, and cooler things are more dense, so they sink. Radiation is heat transfer through electromagnetic waves. There we go. You got it. So you're pretty much done with heat transfer. You just have some questions to answer on your piece of paper. You need to answer both the convection and radiation questions. There are 3 of them. And then you also need to do the conclusion. And there's some questions there for the conclusion. And then some boxes where you need to practice labeling things as either conduction, convection, or radiation. Sound like a plan? Watch the plane go by. Ooh. There it is. Welcome to my home.